welcome to our channel. By seeing the fundamentals of mathematics, today we are going to see about identities. Okay, it's a very easy and also important. Why for identities? So identities we are going to use to solve the algebraic expressions in a very easiest way. So that's why we are using identities. Now see, okay, how far it is very important to solve the algebraic expressions. Okay, so based on this algebraic expression concept, already made a video. Okay, I put it in the description box, so please watch it. Okay, so now let's see identities. So identities we are going to write in the form of very standard identities. Why it is very standard means very often we are going to use the standard identities. It will be very useful to solve any such a category of the algebraic expressions. So now the first one is a plus b the whole square. It is equal to a square plus 2ab plus b square. That is called as a first standard identity. Second one is a minus b the whole square, which is a square minus 2ab plus b square. Okay. Third one is a plus b into a minus b. Just a multiplication of the two terms, a plus b, a minus b, which is a square minus b square. So the first three are called it as a standard identities. And one more, the very important results we are going to use, that is x plus a into x plus b. If you are getting like this format, then we can make it use this result is x square plus a plus b into x plus ab. See, we no need to multiply in the as usual methodology for the solvation of the two multiplication term. You just write the variable square plus the constants, that is addition, a plus b constant. Okay, multiply by the such a same variable plus the third term, it must be a multiplication of the constants a and b. If you are writing like this, we can save our time and also we can write it in a single step. So that is the beauty of the standard identities. Okay, and also this result. Now we will see some problems based on the solvation of the algebraic expression using identities, right? So now let's see the first problem. So what is our first problem? xy plus 3z whole square. xy plus 3z the whole square. By seeing the problem itself, you must think and compare the identity. Which one is suitable to solve such a problem? Okay. So this is kind of format a plus b the whole square format. So the first term we can take it as a, second term consider as b. So a plus b whole square. Now you can make it use the first identity. So how to write this? Now let it be a equal to xy and b equal to 3z. Okay. So what is your identity? Now we are going to make it use the identity a plus b the whole square equal to a square plus 2ab plus b square. Okay, so wherever a and b, you can make it use this term, what is given in the problem. Okay, so here we can write xy plus 3z the whole square, which is equal to, make it use the result. So what is that? A square, simply a square. What is our a? X into y. So xy the whole square plus 2 into a into b. A is xy, b is 3z. So xy into 3z plus b square. B square is 3z. So you can write 3z the whole square. Okay. Now you can make it simplify the right hand side. So this will be xy the whole square. Xy the whole square we can write x square, y square. Each term power. So this we can write x square, y square. See the second term. Second term we are getting plus. So write the plus. And then first you can multiply the number, numerals. So 2 into 3 becomes 6. So 6. And then you see the variable. All are different variable, right? So x, y and z. So under the multiplication you will be simply getting x, y, z. Okay. Then third term plus 3z the whole square. 3z the whole square means, so make it use the result here. So that is a b the whole square equal to a square b square. Okay. This result only we are using. So what happened? A, b the whole square. First term is a, second term is b. So 3 square is z square. What is 3 square? It is 3 into 3. So you will be get 9 into z square. Okay. So by using the identity, you are getting a very easiest way of the result. X square y square plus 6xyz plus 9z square. So this is all as a solution of such a problem xy plus 3z the whole square. Okay. Now 0.4, just move on to the second problem. Minus 0.5 q the whole square. Okay. Once again the same. Make it use the standard identities. It will be very easy for our calculation part. So this is looking like, see the second standard identity. What is that? A minus b the whole square. Okay. Just to make it use here. So what is that? Use the identity. So what is that? A minus b the whole square equal to a square minus 2ab plus b square. Okay. You just make it compare. So first term we can take it as a, second term you can take it as b here. So what should be here? A equal to 0.4p and b equal to 0.5q. You should not take minus here, okay, because under our standard identity itself we are getting a. So this is a, this is b. Similarly, under this negative sign, this is our a, this is our b. So 0.4p is a, 0.5q is our b value. Now just to replace a and b value in our identity result. So it will be become as 0.4p minus 0.5q the whole square equal to first term a minus b the whole square. So a minus b the whole square. Same concept. Okay. So a square. So a square means what? A is 0.4p. 0.4p the whole square. Okay. Then put minus. What is that? 2 into a into b. A into b. A is this, b is this. We just multiply 0.4p. Okay. And b is 0.5q. You will be getting like this. Plus b square. So plus b square. So what is your b square? 0.5q the whole square. So you will be getting like this. Okay, wow. So this is, you will be getting as 0. So now we are going to use the standard identities. So a minus b the whole square. This one how to write? A square. So you will be get 0.4p the whole square. Then minus 2. A into b. So you will be get what? 2 into 0.4p into 0.5q. You will be getting like this. Next to what? Plus b square. What is your b square? 0.5q the whole square. Okay. So now you just make it use of the standard identity number 2. A minus b the whole square. You will be getting like this. The next one is you must simplify it. So how to simplify? This is equal to. So what is that? 0.4p the whole square. So you will be get what? 0.4p whole square means 0.4p into 0.4p. So 0.4 whole square p square. You will be getting like this. Okay. Then minus Here you will be get what? 2 into 0.4 into 0.5 P into Q. So you will be get what? 2 into, I am writing together numbers first, then PQ. You will be getting like this. Then plus this we can write 0.5 whole square, then Q square. Okay. So next what will you get? 0.4 whole square. So how to write? 0.4 whole square. So this is 0.4 multiplied by 0.4. Okay. While you are getting the decimals under the multiplication, first you can multiply the numerals. So 4 into 4 you will be getting 16. Now you see here one place decimal, here also one place decimal. By the multiplication you must put the decimal, okay, after the 2 digit, because here 1 digit, here 1 digit. By multiplication 2 digits, okay, you must be take it as a point here. So you will be getting like this. So 0.16, okay, that we can make it use here. So 0.16, 0.4 the whole square is 0.16. Then P square write as it is. Okay. Next we can write what? Here you will be get, okay, 2, and then first you can multiply these two. So what you will be get? 0.4 into 0.5. Same concept, 2 multiplied by 0.4 into 0.5 means as the same. First you can multiply the numerals. So 4 5s are 20, isn't it? 4 5s are 20, and then 2 digits both are having a 1 place decimal. So 1 place decimal, 1 place decimal. So 2 decimals, after that you must put the dot here, decimal. So 0.20, okay. Then here is 0.20, simply we can write it as 2 itself. So 0.2 itself we can write, because this is having no values. So you will be getting like this. Now you can multiply. First you can multiply here 2 into 2, 4, and then here there is no decimal place. So here you can 1 place decimal. So you can write 0.4. So the answer is 2 into 0.4 into 0.5. Simply you will get 0.4. Okay. So I am writing here 0.4. Minus is there. So 0.4. Then remaining PQ. Okay. Plus. So once again, here what will you get? 0.5 the whole square we are getting. So 0.5 the whole square, how to write again? 0.5 the whole square, which is equal to 0.5 into 0.5. As the same, multiply the numerals as first. 5 is a 25. Write 25. Here 1 place decimal, here also 1 place decimal. So after the 2 decimal, you can put the decimal point. So you can write 0.25 is the multiplication value. So I am writing here 0.25, then Q square write as it is. Okay. Now you see the second problem, 0.4 P minus 0.5 Q the whole square. Finally we are getting a, here the expression is 0.16 P square minus 0.4 PQ plus 0.25 Q square. So this is a solution for the second problem by making use of the second standard identities. Okay. Now let's move on to the third one. Okay. Now so third problem is 153 the whole square minus 147 the whole square. So while you are getting this, usually what we can do? 153 into 153 minus 147 into 147. See how big number it is. Okay, ma? So we need to multiply numbers and then we are going to subtract from one from another. Okay, it will be taking a very lengthy step, isn't it? to avoid such a cases, for exam purpose, we need to very careful, okay, to save our time. So such a cases, the identities are very much useful. So just make it use of it. The very important case is which identity, where, how we are going to make it use. So that is a very important thing. Okay. By seeing this problem, what will you get? 153 the whole square minus 147 the whole square. So two square terms under the subtraction. Just to make it use of the standard identity. So just check it out. So which one is we are going to make it use. So now you see the result very carefully. Now see the third one. Right hand side we are getting a square minus b square. So square terms under the subtraction. Now we are going to make it use this. So problem is given under the right hand side format. Make it use the left hand side because both are equivalent. Any one of the side we can make it right. Which one is convenient for us? So now this is under the format. The problem is under the format a square minus b square format. Okay. Now what identity now we are going to use? So third identity we are going to make it use here. So that is, I am writing like this. Because the problem is given in the form a square minus b square form. Right hand side I am writing anything. Anyone we can write it first. So a square minus b square equal to a plus b into a minus b. Okay. Now what we can make it the use of a and b here? A is 153 and b is 147 here. Okay. Now let a is 153 and b is 147. Okay. Just to replace this a and b values in the identity. So it will become as what? 153 the whole square minus 147 the whole square equal to a plus b into a minus b. So it will become as a is 153 plus 147 under the addition. Next we need to subtract the same values here. So you will be get 153 minus 147. You will be getting like this. Okay. Now this term square terms here we just made it as a very simple term here. Okay. Just to make it addition first. So ones place 7 plus 3 you will be get what? 10. Okay. Then 5 plus 4 it is 9. 9 plus 1 is 10. Okay. Plus 1. So 1 is reminder. 1 plus 1 is 2. So 2 plus 1 is 3. So if you are adding these two you will be get 300. Now we need to subtract this. 153 minus 147. So the subtraction you will be get what? The very simple value, it is 6. Okay. So you will be get simply 6. Now these two terms under the multiplication. We need to multiply. See how simple it is. Okay. We made it very simple multiplication. So here just multiply. 3 6 are 18, isn't it? So 18 and 2 0. So finally we are getting the answer 1800. Okay. So 153 the whole square minus 147 the whole square. The answer is 1800. By made it use of the third identity, our calculation part becomes very simpler. Okay. So next we can move on to the fourth one. Yes. Now we are going to see the fourth problem. 9.7 into 9.8. Okay. So by seeing this problem is the multiplication of the two decimal. By making use of the standard identities or result, okay, now we are going to see how we are going to make it as a very simple calculation part. By direct multiplication also we can make it use. Okay. Otherwise by seeing the result, let's see how it's going to be very convenient for us to do the problem without having any that is proper multiplication. Okay. So now let's see. First by seeing the problem you must come to the point. This point is, that is this number is close to which integer? So 9.7. So 9.7 is very nearer to the value 10 integer. Okay. So now what happened? If you are getting a 10 means, so 9.7 Now take it as a integer 10 here. Okay, 10, and then subtract it. By subtracting you will get what? Here 0.3 you will be get. By subtracting you will get 0.3. Same way 9.8. That is also very nearer to the integer 10. So 10 subtract with 9.8. So you will be get what? 0.2. Okay, you will be get 0.2. So this is that is very minimum value. You will be get 0.3 and 0.2. So here this 9.7, how to write this 9.7? We can write it as 10, okay, minus 0.3. Yes, of course. If you are getting 10, 9.7 means only the difference is 0.3, isn't it? So 10 minus 0.3 means you will get the value 9.7. So this only I am writing in this way. Okay. Next, 9.8 multiplication. This how to write? 10, okay, minus 0.2. So you will be right minus 0.2. So see here 9.7, 9.8 and just written in the form 10 minus 0.3 into 10 minus 0.2. Okay, ba? So why you are writing in this way? You are writing in this way. This we can check it out. So what is that? X plus A, X plus B format. Either you can get plus or minus. Okay, that is the immaterial. So now this one actually how to write means 10, write plus, because plus into minus is what? Minus again. So if you are writing like this, you will get minus 0.3. Both will be similar, right? Next, multiplication of 10 plus into minus of 0.2. Why I am writing like this means, okay, to compare, it will be very easy for this result. Okay, x plus A, x plus B. So x plus A multiply with x plus B. Okay, the first term it must be similar. Okay, so now let it be use the result. What is such a result is x plus A into x plus B, which is x square, plus addition of the two terms, that is second term A plus B into x, plus multiplication of the two terms, so that is A and B. So AB. Okay. Now by comparing you will get, what is that? Put x is 10 here. X is what? First term 10. For both the term, first term is 10. Okay. And then what is your A? A is minus 0.3. Okay. Same way you just compare x plus A, x plus B. So your B value is minus 0.2. So B is minus 0.2. Okay, A and B, it may be positive or negative. Okay, you must be very careful to write the that is plus value, minus value for each and every term. Okay, it may be one term is plus, another term it may be minus. So you can put it like this. Okay, plus into minus concept if you are writing means you can, by comparing itself you can get clear idea. Okay, you won't get any mistake. Then what we can do is just replace in the result. So what it will be? 10 plus minus 0.3 multiplied by 10 plus minus 0.2. Okay, this term x plus A into x plus B, which is equal to, what is that? X square. What is our x now? It is 10. So you will get 10 square. Right? Next, plus A plus B into x. So what is A plus B here? Minus 0.3 minus 0.2. So minus 0.3, then plus minus 0.2. Okay. So this is A, this is B. A plus B. Okay. Into x. What is our x? X is 10. So 10 under the multiplication. Okay. Then plus A into B. What is your A? Minus 0.3. So you will get minus 0.3 minus 0.3, then multiply by minus 0.2. You will be getting like this. Then what happened here? This is 10 square. 10 square is very simple, no? 10 multiplication is very simple. So it is 100. Okay. Then here you check it out. Both the terms by the addition, both the terms are we are getting a negative term. So minus 1 minus 2 is nothing but minus 3, isn't it? So you will be get minus is common here. Minus, okay, we can put it as common. Then remaining term 0.3 plus 0.2. I just taken outside minus. So minus into plus become minus here. Then multiply by 10. Okay, here let's see. Minus, this is also minus. Under the multiplication, minus into minus, it becomes positive. Here also positive. Positive into positive becomes, once again it is positive. Okay, so plus. So here what will you get? 0.3 multiplied by 0.2. So you will be getting like this. Now again write this 100 minus 0.3 minus 0.2. 0.3 plus 0.2. So what will you get? 0.3 plus 2 is 5. So you can write here. So 0.5. Okay. Multiply by 10. You will be get multiplication with 10 plus. Here what will you get? 0.3 and 0.2 under the multiplication. So this one how to write? 0.3 multiplied by 0.2. So what we need to do? We must give a priority for the multiplication of the numerals as first. That is numbers. 3 2s are 6, isn't it? 3 2s are 6. And then here 1 decimal place, here 1 decimal place. So 2 decimal, after that we must put the decimal point. So 1 decimal is there. So you can make it use 1 0 here, put the point. So 0.06, that is the value here. So here you will be getting 0.06. Okay, you will be getting like this. Next, by continuing this, you will be get what? So this value will be, so 100. Then see here minus 0.5 into 10. So what will you get? 0.5 multiplied by 10. So multiplication of that 10 is coming. So you can multiply the numbers as usual as first. So 5 tens are becomes what? 50. Isn't it? 50. Here 1 decimal place. Here there is no decimal point. Okay. So after the 1 decimal you must put the value. Okay, that is decimal value. So after the 1 decimal means you will be getting like this. So you will be get 5. 5 is the value. Okay. So here you will be get what? Simply 5. So 0.5 multiplied by 10 means the answer will be simply 5. The integer is 5. So this you can write simply minus 5. Then plus 0.06. Will be getting like this. So it's a very simple, no, 100 minus 5. From 100 we need to subtract only 5. So you will be get what? 95 plus 0.06. So how to write this? 95 integer, you must be add with, what is that? 0.06. So 0.06 decimal. So here we can write, for our convenient, for the clarification we can write 0 0 because there is no decimal point. We can write like this. By adding you will get what? 0 plus 6, 0, 0 plus 0 is 0, and then here you 95 plus 0 you will get 95. So 95 plus 95.06, that should be the value. So 95.06. Yes. So you will be getting like this. 95.06 is the answer for the multiplication of these two terms. 9.7 multiplied by 9.8. By making using this result, we just made it as the simple multiplication part. Okay. So altogether, hope you understand this concept very well. So by here in this session, we just saw the identities are important, how it's make it as a very simple calculation part of the expressions. Okay, so standard identities, 3 standard identities and one more result we just made it use to solve the problems. Okay, yes, you understood well, I hope so. Thanks for watching.